This is the brief on Meshtastic infrastructure deployment. So we're looking at a personal story, right? It's about someone who took a cheap, off-the-shelf Meshtastic LoRa device and figured out what it really takes to make these off-grid networks actually work. Okay, first up, physical placement is everything for LoRa radio. This person was on the 8th floor, and they found that just being up high with a totally clear line of sight was the biggest deal. You know, that clean path for the radio signal, it's called a Fresnel zone, and keeping it clear is just crucial. Basically, where you put the thing matters more than any fancy settings or expensive gear you could buy. All right, second. Once you've got the placement sorted, it's all about stability. You have to treat the device like permanent infrastructure, not a personal gadget. So its role was changed from a sleeping node to a dedicated, always-on router. This meant disabling settings like deep sleep, since it was always plugged into the wall anyway. It was even given a neutral name, Abracadabra, to show it was a community asset. And finally, the last lesson is, well, the goal is to be boring. Meshtastic is at its best when the whole system is so stable you just forget it's even there. It's that quiet, consistent uptime where the node is just doing its job routing traffic in the background. That's what really makes the whole network stronger for everyone. So really, stability, placement, and uptime are what truly transform a simple gadget into resilient infrastructure.
Welcome to the Deep Dive, the place where we really try to cut through the noise and deliver the critical insights you need to truly understand the mechanics of the world around us. Today, we are setting aside, well, everything we normally talk about, 5G, fiber optics. We're going to explore something radically different. A fascinating world of decentralized, off-grid communication built on low-power radio technology.
A technology called Meshtastic.
Exactly, Meshtastic.
And this is, I think, a really perfect deep dive into resilience. We're tracing the journey of one specific user, someone who bought a cheap gadget purely out of curiosity, and we get to watch them almost accidentally transform.
Transform into what exactly?
Into a critical, permanent piece of their local community's digital infrastructure. The sources we have today, they just chronicle this entire evolution, mapping the shift from, a $55 purchase to an essential network backbone.
And that's the core mission today for you, the listener. We're analyzing this fundamental shift, how a minimal initial investment combined with a crucial insight about the physics of radio and, well, the nature of network needs, turns a personal experiment into a public utility.
Yeah.
Our focus will be on the technical details behind this transformation, tracing the user, Chris Abraham's experience, from the moment he first powered it on to, well, stabilizing a permanent routing node in the busy Mesh-DC area.
And the underlying concept here is so critical for modern communication resilience. We're exploring how small, accessible hardware can let you just circumvent these fragile, centralized systems like cell towers or Wi-Fi hubs.
But it's not just about the tech.
No, not at all. To make this work, there's this required, and I'd say often uncomfortable, shift in mindset. You have to move from thinking about individual convenience to prioritizing network-wide stability. Communal presence.
Okay, let's unpack this starting at the absolute beginning. The user, as you said, wasn't a prepper, not a licensed ham radio operator.
No.
It was just a low buy-in curiosity, spurred by how accessible the technology has become. He bought a cheap purple Meshtastic device off Etsy for about $55.
That's the key, that price point.
That's the open door for this whole experiment, right?
Yeah.
So what exactly is Meshtastic, and why is it structured to be so approachable for someone who isn't, a radio expert?
Meshtastic is fundamentally an open source system. It's designed to facilitate short text messaging and location sharing over something called LoRa radio.
Okay.
The genius of the project isn't just the hardware, which is usually cheap off-the-shelf components like ESP32 microcontrollers. The genius is the open source firmware that wraps it all up.
It makes it simple.
It makes setup as easy as pairing a Bluetooth device to your phone, and critically for local operation, it requires absolutely no centralized external services, no cellular, no Wi-Fi. It's entirely self-contained.
So let's dig into the core technology that's powering this, which is LoRa. This is the bedrock. We use Wi-Fi and 5G every day.
Yeah.
Why is LoRa the right choice for this kind of decentralized, resilient application, even though it's, painfully slow compared to the alternatives?
That slowness is its superpower.
Wow.
It really is. LoRa stands for long range, and it uses a technique called chirp spread spectrum, or CSS modulation. And this is a deliberate, highly effective trade-off.
A trade-off of what for what?
It sacrifices high bandwidth. And you are definitely not sending photos here. You're sending maybe, 20 bytes of text at a time.
Okay.
And in exchange, it maximizes two things: distance and efficiency. Because the data rate is so incredibly low, you can pull the signal out of the noise floor over vast distances. We're talking far exceeding typical line-of-sight limits for other radio types at the same power level.
So if I'm understanding this correctly, the network designers, they looked at the requirements, sending a basic text message or location update during an emergency, and they said, we don't need a massive digital highway. We just need a robust, low-energy trail.
Exactly. It's optimized for minimal data transfer and maximum resilience. These devices can run for weeks, sometimes a month, on battery power because they only need to transmit these tiny little packets of data every now and then.
And that efficiency, that's what makes the network sustainable and cheap to maintain.
It's perfect for status updates and critical short communication.
Now we have to move to the concept that really defines the utility of the system, which is the mesh. This is the crucial architectural difference that provides all that resilience. Let's compare this structurally to the centralized model most of us are used to.
Right. So as you said, standard cellular or even your home Wi-Fi is centralized. It follows a hub-and-spoke model.
One to many.
One to many. If that central hub, the cell tower, or your router, if it fails, the spoke, your phone or computer is just completely disconnected. Game over. The mesh concept is, well, it's anarchic in the best possible way. Every device, every node communicates directly with its neighbors. And here's the key feature Meshtastic enables. Every node can act as a fully autonomous relay.
So my device isn't just talking to the network. It's actively being the network for other people.
Precisely. If you send a message and the destination node is too far away for your radio to reach directly, your closest neighbor node, it just grabs that packet, stores it for a millisecond, and then forwards it to its neighbor, and so on.
So messages can take multiple hops.
Multiple hops. And Meshtastic manages all this through an adaptive routing protocol. It automatically builds and maintains a table of known neighbors and what it thinks are the most efficient paths.
I get the resilience advantage. Redundancy means no single point of failure. But here's a question. If every node is constantly relaying traffic, isn't that a massive drag on the battery life of the average person who's just carrying this device in their pocket? How does the network stop the core relay nodes from getting overwhelmed or, just draining all the mobile users' power?
That's a highly relevant technical challenge, and it goes directly to the resource management strategy of the firmware.
Okay.
Meshtastic's firmware is built to manage this intelligently. First, because LoRa transmissions are so incredibly power efficient, the energy cost of forwarding a small text packet is minimal. It's often far less than the cost of you trying and failing to reach the destination directly with a higher power broadcast.
So it's actually more efficient to whisper to your neighbor than to shout across the valley.
That's a great way to put it. Second, the network limits the number of hops a message can take. This prevents infinite loops and just uncontrolled flooding of the network with junk packets.
Sure, makes sense.
And third, Meshtastic uses this intelligent neighbor discovery. It prioritizes strong, stable links, which inherently favors stationary-powered nodes over the mobile, transient ones.
And that dynamic prioritization, that sounds critical. It really sets the stage for our user's journey. So if the network itself favors stability, the core value proposition for you, the listener, isn't about replacing anything. It's about ensuring against failure.
Exactly. This technology acts as a resilient complement. It's not about high throughput, it's about guaranteed message delivery when traditional infrastructure fails. During a localized power outage, a communications blackout, a natural disaster.
Anything like that.
It provides this crucial layer of communication independence, ensuring those essential short messages, "Are you safe? Where are you?" can get through regardless of what's happening with the utility grid.
It effectively transforms communication from a centralized paid service into a decentralized, collaboratively built utility. That's a profound shift in control.
It really is.
So let's pivot now to the user's specific experience, because that really highlights this philosophical shift from being a user to being a component of the utility.
Okay.
When the user first activated their cheap purple gadget, the source material describes this initial sense of, well, disappointment. It worked, but it didn't feel like a functioning network.
Yeah.
Why was there that disconnect?
The disappointment, it stemmed entirely from centralized expectations. He paired it, sent a few test messages, and just watched the node list fluctuate wildly.
So people were just popping in and out.
Constantly. Nodes would appear, transmit maybe once and then vanish. Traffic was sparse. The user observed that most activity just looked like people checking in, not sustained routing behavior.
It felt ephemeral.
Right. It felt like a collection of individual experiments rather than a true network fabric. I mean, if you're used to checking your Wi-Fi status and seeing 20 neighboring networks, this quiet, inconsistent behavior, it feels like a failure.
The technology was doing its job, but the critical mass of community presence wasn't there yet to make it feel robust. And then the user made this tiny, almost trivial decision that changed absolutely everything.
The first meaningful decision. Uptime is everything.
He just left it on.
He simply left the device plugged in and running indefinitely. And he admitted this decision didn't feel consequential at the time. He was busy, he forgot about it, but it stayed on. And that single act was the catalyst for his transformation into an infrastructure component.
And this action embodies that key, almost paradoxical insight about decentralized systems like Meshtastic. The network doesn't reward active interaction. It rewards continuous, stable presence.
This is a critical technical insight wrapped in a simple behavioral choice. It's so important. In a mesh, unstable nodes, those that turn on for 30 minutes and then disappear, they actually create friction.
How so?
They cause what we call route flapping. The network learns a route through that node, it starts sending traffic that way, and then the node vanishes. This forces the entire network to waste energy recalculating the path and retransmitting the message.
It's inefficient.
Highly inefficient. Nodes that stay up and maintain constant presence, they become statistical anchors. They're reliable hops. They increase the successful hop count across the mesh, confirming the network stability, and over time, other nodes actively prefer routing through them because they know that connection will be maintained.
So stability minimizes inefficiency for everyone else. By simply existing reliably, the user began reducing the power consumption and increasing the reliability for every other mobile user in his region.
Precisely. He went from being a consumer occasionally checking in to being a foundational, silent contributor to a public utility. And this is where the identity shift came into play.
Right, the name. He initially used ABRA, which was short for his name, Abraham, but he realized it felt too personal for what was becoming a public resource.
And that realization is the final cognitive leap. It's the one you have to make to transition from user to architect. Infrastructure can't be tied to an individual's identity.
So what did he do?
He kept the identifier ABRA, but he redefined it. He changed it to abracadabra.
Abracadabra.
And this name choice is perfect. It's abstract, it's memorable, it's playfully neutral, and most importantly, it communicates that this node is autonomous. It's not subject to the personal whims of the operator.
It's a signal to others.
It signals. This is a permanent stationary relay point ready for community use. The device itself was telling a story of commitment even before he really optimized the physical setup.
But commitment only goes so far without physics backing it up. And here's where it gets really interesting. The source material emphasizes that the physical location determined the device's success more than any software setting.
Oh, absolutely.
You just can't software patch bad geography.
That is the absolute truth of radio frequency communications, especially when you're using LoRa's low power. The user lives on the 8th floor in Arlington Heights. His windows face southeast.
Which turned out to be critical.
Critical. He quickly realized, just through simple observation, that he had an entirely unobstructed line of sight. His view cleared a golf course and a significant stretch of low-rise terrain, projecting all the way toward the Gaylord MGM area.
That elevation and clear view, I mean, that's worth thousands of dollars in commercial radio equipment upgrades. But here, it was just the reality of his lease agreement.
It's the ultimate geographical advantage. For LoRa, placement is paramount because you're trying to overcome the Earth's curve and ground-level obstructions. And this brings us to a key piece of jargon we really need to unpack.
Which is?
The Fresnel zone.
The Fresnel zone. Okay, it's often confused with simple line of sight, but you're saying it's far more complex.
It is.
Yeah.
So tell us what a Fresnel zone is, and why was that golf course so important to its success?
Okay, so think of a radio transmission not as a single thin laser beam of light, but as an expanding ellipse, like a football shape, around the direct line of sight between two antennas.
Right.
The Fresnel zone is this required elliptical area, the first Fresnel zone specifically. That has to be kept clear of obstructions to ensure you get maximum signal strength. If 60% or more of that ellipse is obstructed by something, signal quality degrades dramatically.
even if you can still visually see the other antenna.
Exactly. That's the counterintuitive part.
So even if the user could see the Gaylord MGM, if they had a dense tree line or small hill just below their direct line of sight, even though it wasn't blocking the view.
The radio waves that are traveling in that football shape around the direct path would still be degraded.
Precisely. Objects like buildings, dense foliage, even the surface of the ground, they cause reflections and phase cancellation. We call it multipath interference. The golf course and the low-rise terrain provided the ideal, almost pristine clearance required for that Fresnel zone.
So the signal could just propagate smoothly over vast distances.
The environment was doing the vast majority of the heavy lifting. The user had cheap hardware, but a $1 million RF location.
Once that physical reality was recognized, the logical conclusion was that the device could no longer be treated like a casual gadget.
Correct. When the user cemented the node's stationary status, the purple box, the whip antenna, always powered, basically bolted down metaphorically in the window, he realized treating it as a standard node was just wasted potential.
Because a standard node is designed for portability and sleep.
Right. A device in such a prime RF location that is allowed to sleep, to save power, even for a few hours, is just fundamentally misaligned with its physical advantage.
Which then drove the functional change in the software, switching the device role from a standard node to a dedicated router.
And this was the functional declaration of its new infrastructure identity. The router role ensures the device is awake and actively forwarding messages, maximizing its contribution to stability and range for the entire Mesh-DC community.
It signifies that the operator has accepted that responsibility.
Yes. They've accepted the responsibility of maintaining a key network relay, moving beyond just personal use to community service.
But switching to router mode introduced a significant friction point. The device's internal behavior changed in ways the phone app didn't really explain well, and this led to a lot of frustration for the user. What was the core technical conflict that emerged here?
The conflict was architectural, and it all stemmed from power management. When you designate a node as a router, the firmware scheduler, it aggressively prioritizes the core mission.
Which is maintaining the radio link and processing packets.
Exactly. And to achieve this reliability and conserve power, in the general case for a battery device, it deprioritizes non-essential functions, particularly the control plane access via Bluetooth Low Energy, or BLE.
So the device was doing its job perfectly, routing traffic silently and efficiently, but the human operator trying to connect with their phone suddenly found the device inconsistent and hard to manage.
Exactly. From a phone-centric perspective, it just felt buggy. You try to connect via the app, and it would time out or fail because the BLE control plane was scheduled to sleep or delay interrupts to give the radio stack priority.
And this also minimizes potential self-interference, right?
Right. Any processing power diverted to maintaining a constant BLE connection is power not available for radio transmission, or it might induce noise into the RF chain. The device was maximizing network utility at the expense of user convenience.
And this really highlights why troubleshooting these decentralized tools so often requires bypassing the simple app interface and digging deeper.
You had to.
The user accessed the device over USB to view the console and the actual configuration settings. What did that technical deep dive reveal?
It confirmed the scheduling conflict. The control plane was indeed sleeping or being heavily deferred while the radio link remained continuously active. The user realized that while this aggressive power saving was essential for a battery-powered device out in the field,
it was completely unnecessary for his permanent wall-powered setup.
Totally unnecessary. He had unlimited power but was suffering the usability consequences of a power-constrained configuration.
So since power was no longer scarce, the device was permanently plugged into a USB-C wall wart. He was free to compromise efficiency for stability and convenience. This is a fascinating trade-off, using an abundance of power to solve a human interaction problem.
It is.
What were the 3 specific configuration adjustments he made to stabilize that control plane?
The 3 adjustments were highly targeted. They were specifically aimed at just overruling those power-saving defaults. First, he explicitly disabled deep sleep entirely. The node would never enter a low-power state, ensuring instant responsiveness.
Okay, that's a big one.
Second, he significantly increased the Bluetooth wait time, or the BLE advertising interval. This just extended the window during which the device's control plane remained available to accept connections from the phone.
Mitigating those intermittent connection issues.
Yep, and third, he just left the display on full-time, showing status information.
Let's look at that first change for a second. Disabling deep sleep. While they have unlimited power, are there any negative consequences for the hardware or the surrounding environment, like excessive heat or reduced component lifespan?
That's a crucial technical nuance the sources imply but don't really dwell on. And yes, disabling deep sleep means the microcontroller is running at a higher clock speed and duty cycle constantly. This generates more heat.
Of course.
And in these cheap, mass-produced enclosures like the $55 purple box, this continuous heat can absolutely reduce the lifespan of the internal components, particularly the capacitors and the SO itself.
So for a cheap router, this might just be acceptable wear and tear.
It's a trade-off. You maximize lifetime stability at the potential cost of component longevity. He chose maximal operational stability now, accepting that the device might fail earlier than if it were managed more conservatively.
And the result, once these changes were implemented, was stabilization.
Yes, the device stopped oscillating between states. The BLE access became reliably instant. And crucially, none of these adjustments compromised the device's core routing function. In fact, keeping it fully awake arguably improved its routing responsiveness.
So he successfully molded the aggressive, power-constrained router architecture into a stable, convenient piece of permanent infrastructure.
And once that stability was achieved, the user noted the ultimate goal was reached. The device became boring.
Boring is best for infrastructure.
Absolutely. When a router is stable, doing its job well, you should never have to interact with it. If you are constantly troubleshooting your relay node, it is failing its primary purpose.
The abracadabra node settled into its optimal state.
Silent, reliable, consistently forwarding traffic, and just radiating its signal perfectly from that 8th floor window.
So while the user was busy taming their individual router, the surrounding local network in the Arlington and Mesh DC area was simultaneously maturing. The user noted an increase in traffic and stability that was coinciding with his adjustments.
This was a synergistic effect. The stabilization of key relay nodes like Abracadabra created this positive feedback loop. The local network began converging on a preferred configuration standard,
The long fast preset.
the long fast preset, and this preset is a critical middle ground in the LoRa settings.
Okay, so what exactly does long fast balance, and how does it compare to other choices, like long slow?
So Meshtastic lets operators choose different combinations of spreading factor, or SF, bandwidth, and coding rate. Long slow, which prioritizes maximum range, often uses a very high spreading factor. This makes messages extremely slow. We're talking seconds to transmit a single text packet, and it consumes a lot of airtime.
Clogging up the frequency.
Right. Long fast sacrifices a tiny bit of that maximum theoretical range by using a slightly lower SF and a higher bandwidth. This results in much faster transmissions, reducing the time the radio occupies the airwaves.
Reducing the duty cycle.
Exactly, which is crucial in congested urban or suburban areas. It's the sweet spot for a functioning medium-speed mesh.
And the maturation of the network was visible not just in the volume of messages, but in key performance indicators like increased hop counts and improved ACK frequency. Let's define those for the listener.
Sure. An ACK is a simple acknowledgement. It's a confirmation signal sent back to the originating device that the message was successfully received by the intended recipient.
So it's a delivery receipt.
It's a delivery receipt. And in a robust mesh, a high ACK frequency confirms that messages aren't just being broadcast blindly into the void, they're traversing the mesh, being successfully relayed through multiple hops and reaching their destination reliably.
And the increased hop counts.
Increased hop counts mean messages are successfully traveling 4, 5, or even 6 nodes deep. That shows the physical range and depth of the network has increased significantly. It's using stable nodes like the 8th floor Abracadabra node to bridge previously unreachable gaps.
So the local RF network was humming along quietly, proving its decentralized resilience.
Yeah.
But then the user decided to connect the node to the internet via MQTT. This is a critical point where the local physical network touches the global digital map.
And this step is purely for visibility and legibility. He enabled MQTT, the Message Queuing Telemetry Transport Protocol, which is perfect for publishing small pieces of data over the internet.
What data is it sending?
The node sends metadata about itself, its identity, its location, its last active time, and its known neighbors to a centralized public broker. This data then appears on the global Meshtastic map.
Now, it is absolutely crucial to clarify the distinction here. Enabling MQTT does not mean your text messages are suddenly being sent over the internet.
Absolutely not. Local messaging remains 100% over the LoRa radio waves. The message content itself is not compromised by the internet connection.
It's just a status update.
It's just a status update. MQTT simply provides global visibility to the node's metadata. It abstracts that physical purple box in the window into a legible digital icon on a map, which allows the wider Meshtastic community to understand where coverage exists. It's an operational status report, not a communication conduit.
So if the power grid failed locally, the radio communication would continue completely unabated, but the icon on the global map would simply go offline.
That's the precise functionality. The local resilience is maintained. The internet connection is strictly a convenience for meta-level coordination and mapping.
And this leads us to a fascinating paradox, which was highlighted by the user's experience. These two distinct layers of operation. You have the physical, decentralized radio layer, and then you have the meta-human coordination layer.
It's the centralization of decentralization. It's a great term for it. The user noted that almost all the meta work coordinating was preset to use, like long fast troubleshooting, community-wide outages, debating optimal node placement, and generally managing regional awareness. It all happens entirely off-network.
Primarily, this happens through platforms like the Meshtastic Discord server.
Right. The RF layer is decentralized, silent, and passive. It's just route and traffic based on physics and programming. But the human element, it requires coordination, discussion, and consensus, which, by human nature, centralizes onto a platform like Discord.
So you need a centralized place to discuss how to optimize the decentralized system.
It's a paradox, but it works. This is where the community decides, for instance, that Abracadabra is a critical relay and should always be configured to use the fastest possible long-fast preset to maximize the benefit for the whole community.
So the technology offers total independence, but the human requirement for efficiency and coordination pulls the community back toward a centralized virtual space to make decisions about that independent network.
It proves that even when the means of communication are decentralized, the organizational structure of the people using it will often centralize just to be effective. The Discord server acts as the essential, non-decentralized command center for managing the decentralized RF infrastructure.
This journey from a skeptical purchase on Etsy to a key infrastructural node has provided some really profound technical and philosophical insights. So what does this all mean?
Yeah.
The central lesson learned by Chris Abraham wasn't just about radio settings. It was a lesson in effective contribution. Meshtastic works best when the operator sheds the mindset of a personal user and embraces the commitment of being stable, reliable infrastructure.
And we learned that real infrastructure success hinges on three simple factors: stability, optimal placement driven by physics, and most importantly, continuous uptime. The user didn't need specialized training or massive funding.
Yep.
He simply left a cheap device plugged into a strategically high, well-placed window. The network stability, the community's range, the overall functionality. It all flowed naturally from that single, persistent, active presence. It's a remarkable testament to the power of low-effort, high-impact commitment in a distributed system.
It fundamentally reframes what contribution means in a digital, decentralized age. Sometimes the most valuable thing you can contribute isn't active work or complex interaction, but simply existing reliably in a good spot for the benefit of the collective.
And this contrasts so sharply with the tragedy of the commons, where individuals act selfishly to the detriment of the group resource. In Meshtastic, we see the rewards of the consistent contributor. By prioritizing continuous, stable presence, the Abracadabra node didn't just help its owner. It increased the efficiency and resilience of every other node, thereby rewarding the entire community.
Which raises an important question for you, the learner, to consider as you move forward. If a reliable, resilient network can be quietly built, piece by piece, by individuals who prioritize persistent presence over momentary interaction, what other types of decentralized resilient systems could benefit from the exact same set-it-and-forget-it commitment?
It's a powerful idea.
What local infrastructure, whether a digital relay node, a physical community resource, or even just consistent positive participation, could you contribute to just by staying reliably present? Think about the power of boring stability in a hyperactive world.
Okay, so this critique is about the journey of taking a $55 LoRa Meshtastic device and turning it into a stable, always-on piece of infrastructure.
A router, yeah, from an 8th floor apartment.
Exactly. And the core discovery here, which I think is just brilliant, is that Meshtastic rewards presence more than interaction. So let's just dive right in on how to make the material around that idea even stronger for the community. First off, that conclusion you wrote. The node became boring. and boring is the goal.
Oh, that's the best line.
It's gold. It perfectly captures that shift from a gadget you're fiddling with to, real infrastructure.
It really does. It's so relatable. I mean, anyone who's ever run a server knows that exact feeling of relief when things just go quiet.
Right?
But, and here's the thing, how does the community measure your success? That feeling of boring is great for you, the operator, but for the mesh network itself, it's not really verifiable.
Yeah, that's the tension right there. And it's our first point. While boring is the goal is a perfect narrative ending, defining what makes it boring could turn this personal insight into a measurable standard for everyone.
Because right now, success is just defined as it stopped needing attention.
Exactly. Which, for a new person setting up a router, that's not a target they can really aim for. You need proof you're actually helping.
Okay, but let me push back on that for a second. We are talking about a volunteer hobbyist network here.
True.
Is there a risk that if we start enforcing, rigid performance metrics, KPIs and all that, we might actually scare people off? We don't want to turn running a node into a high-pressure IT job.
That's a really valid concern, and we absolutely have to keep it light. We're not talking about, enterprise-level SLAs or anything.
Okay.
The suggestion is more to just codify what that boring state looks like. Maybe 2 or 3 high-level objective things that show the router's doing its job. A checklist.
So less of an operational metric for the owner and more of a contribution metric for the mesh.
Yes, exactly.
Okay, I like that distinction. So what if we focused on visibility? Since you mentioned seeing more long, fast traffic sticking around.
Right.
Let's propose something like a minimum consistent neighbor count. Just a simple metric that tracks how many other nodes reliably see Abra day in and day out. That proves persistence without getting too granular.
That is super actionable. And to build on that, we could also track the data it's forwarding that isn't its own data.
Ah, so a forwarding rate.
A sustained packet forwarding rate, yeah. It doesn't have to be some specific number, just something that shows it's actively passing traffic for other people. It makes its contribution totally undeniable.
And the beauty of those 2 specific KPIs is that they would perfectly visualize the story you're already telling.
How so?
You could create a simple graph, just a mock-up. Show how unstable the neighbor count and forwarding rate were in the beginning, that whole gadget phase.
Right, all over the place.
And then show how flat and reliable the lines are now in the infrastructure phase. That visual makes the whole point of the documentation concrete. It's powerful.
Making the invisible work visible. I love it. That gives every operator a real target to aim for. Okay, so let's shift gears a bit from network metrics to the actual device mechanics.
The troubleshooting.
Yes, because there's one section in here that needs to be, shouted from the rooftops. That whole process of switching to router mode and dealing with the Bluetooth weirdness, that is such vital, counterintuitive knowledge.
100%. It's where everyone gets stuck.
And what I appreciate is the honesty. You really detail that friction, the clash between phone-centric expectations and the reality of a radio-centric device.
Oh, that's exactly the friction point. The device is designed by default to save battery, right? So it sleeps, it pauses Bluetooth. It's meant to be interactive. But stable infrastructure needs to be present. It needs to be always listening. And that feeling when you can't even connect to your own router to check the logs is just, it's maddening.
I've been there. Right. So the narrative of finding the fix is great. But the risk here is that the actual solution gets buried in the story. If someone's looking for a quick technical fix, they have to read through the whole saga to piece together the checklist of what you did.
That's true. You should probably isolate it. But I do wonder, if you pull it out completely, do you lose that crucial teaching moment? The why is almost more important than the what.
How do you mean?
Well, if you just give a checklist that says disable deep sleep, people might lose the context that the only reason that's okay is because the device is now permanently plugged in. The normal power-saving rules just don't apply anymore.
That's a very sharp point, okay? So we need a hybrid structure. The suggestion is to pull out the fixes into a dedicated, actionable section, like a router stability recipe. but we have to build that context right into it.
I like that. A recipe.
Yeah, and it reinforces the core message: stable infrastructure needs non-default settings that kind of defy portable logic.
Okay, so let's make it a super visible 3-point checklist.
Lay it out for me.
Number 1, power management override. Disable deep sleep. 2, control plane access. Increase that Bluetooth wait time. And 3, visibility. Keep the display on.
And the key part?
Evocative title for that section?
Oh, yeah?
Something like The Paradox of Router Stability, Why You Must Override Power Management.
Oh, that's excellent.
The title itself tells the story. It elevates those steps from just a personal anecdote into like a community best practice.
Yeah, it tells the reader that the pain they're feeling is normal. It's part of becoming an infrastructure steward, not just a device owner.
Okay, so that moves us to our final critique, which is all about physical advantage, location.
Prime real estate.
Absolutely. I mean, 8th floor, Arlington Heights, unobstructed view over a golf course towards the Gaylord MGM. You can't buy that. The environment is doing half the work.
It's a critical, scarce asset, seriously. In a dense area like DC or Arlington, a high-up vantage point with a clear line of sight is so rare. So, the node is doing a great job routing traffic, but just having it be a passive relay feels like an underutilization of that spot. It should be an active reference point for the whole local mesh DC network.
So the opportunity here is an evolution of ABRA's role. Shift it from just a reliable router to a reference node.
A benchmark.
Yeah, a benchmark, used for standardized testing, feeding actionable data back to the community on Discord. Given the stability we just talked about, it's perfectly positioned to be an anchor.
Exactly. If you have the best, most stable location, you shouldn't just be a relay, you should be the measurement stick. To leave it passive is to miss the chance to turn it into a living piece of diagnostic equipment for everyone.
So what are the concrete, actionable steps to make that happen, to make it an active reference node?
Okay, a few options. We can start simple. The first suggestion is to coordinate structured signal checks in the Discord group.
So that's just a social thing, no new hardware.
Zero new hardware. It's just coordination. You get people who are driving or walking around to try and hit ABRA from known geographic points. ABRA's telemetry then serves as the consistent benchmark, and the community can actually map the real-world limits of the network in the region.
That's brilliant. Maximizing the location for zero cost. But we could push it further.
You could.
Since it's permanently installed and power is no object, what about suggesting adding some simple, low-power environmental sensors?
Like air quality or barometric pressure.
Yeah, and publish that telemetry over MQTT. Now, ABRA isn't just a message relay. It's a consistent, stationary, data-rich resource for the area.
And importantly, since the documentation mentions the identity shift from the personal ABRA to the more abstract abracadabra,
Right.
you should lean into that. Frame the node as an official beacon or anchor in the community docs. It totally cements its role as a communal asset, not just someone's personal gadget.
So yeah, we've covered a lot of ground here, but it's all about taking this already strong documentation and just maximizing its value for the whole Meshtastic community.
The foundation is absolutely there. You built the stable piece, which is what a decentralized network desperately needs. These next steps are just about visibility and accountability.
To quickly summarize the 3 main areas for growth then. First, operationalize that idea of boring success into community KPIs. Focus on packet forwarding and neighbor count to prove its contribution.
Right.
Second, pull out those critical router configuration fixes into a clear, actionable router stability recipe for maximum utility.
The paradox of stability. Love that.
And third, evolve the ABRA node from a passive router into an active data-rich reference node by using its premium 8th floor placement for community-wide benchmarking.
You implement those changes, and this goes from being great documentation to setting a high-value community standard. We are really looking forward to seeing the update.
And if you're listening and working on similar infrastructure docs, or really any project that could use a sharp, constructive lens, we invite you to submit your work for a future critique.
Welcome to the debate. We are diving into a really crucial paradox that's coming up with the deployment of Meshtastic networks. Does success in decentralized communication hinge more on smart geography or on smart engineering? We're going to use this case study of a single node in the Arlington Mesh DC area, a personal gadget that really became a piece of core network infrastructure, to explore whether it's the physical laws of radio or the conscious human layers of configuration that deserve the credit.
And that case study is perfect because it really highlights the tension, right? When a low-power mesh network, something relying on LoRa radio, actually becomes reliable, like this abracadabra node did, we have to ask why. What allowed it to stop being, just a curiosity and start being a real utility? The physical environment is obviously a prerequisite, but I'm going to argue that the decision points, the moments of deliberate human choice, are what ultimately unlock that stability.
So the central disagreement is pretty clear. In the success of a system like Meshtastic, what holds primary importance? I'm going to argue for the primacy of, well, physical infrastructure, physics, and sheer presence. The material we're looking at even states that the system doesn't reward interaction as much as it rewards presence.
And I have to challenge that entirely. For me, it's the abstracted human and configuration layers that are the true determinants of utility. They're what transform passive, well-placed hardware into active, reliable infrastructure that a community can actually depend on. Without that deliberate technical choice, that well-placed radio is just, well, it's wasted potential.
Okay, let's start with the evidence for physics. The most critical factor in this node's transformation was simply placement. The owner's location, 8th floor in Arlington Heights, facing southeast, gave it a completely unobstructed line of sight, specifically over a golf course toward the Gaylord MGM. I mean, that is a massive, inherent physical advantage.
Sure.
The owner didn't have to, study radio theory. They just benefited from geography that delivered clean Fresnel zones. For listeners who might be less familiar, that just means the critical space around the line of sight path was clear. The material says it plainly: elevation and clean Fresnel zones matter more than intent. That physical environment, it does most of the work. Then the second factor, continuous uptime, follows from that. The device only became truly consequential after the decision to leave it permanently plugged in and switch its role to router. The consistent traffic, the message traversal, that all followed directly from optimizing that stable physical base. In this model, success is when things get, well, boring.
That's a compelling argument for the necessary conditions, I'll give you that. But necessity is not sufficient. Pure presence is just not enough. The network only gains utility through deliberate human intervention, configuration, and this abstraction away from the idea of it being a personal device. Let's focus on what the material calls configuration necessity. Once the device was switched to router mode, it introduced a lot of friction. The device felt unreliable. It clashed with phone-centric expectations. And why? Because it defaulted to power-saving modes. It required the owner to actively intervene to physically access the device over USB to stabilize it. This meant manually disabling deep sleep and increasing the Bluetooth wait time. These were specific, technical choices made only because power was not scarce. If the owner had just plugged it in and walked away, its unreliability would have socially negated its perfect physical placement.
Okay, but...
And furthermore, the human layer is also crucial for just managing the concept. The initial handle, Abra, felt, and I'm quoting, too personal for something that was supposed to function as infrastructure. The deliberate choice to reinterpret it as abracadabra shows that even the identity has to be abstracted to fit an infrastructural role. This is sociological work. And finally, the utility didn't just appear in a vacuum. The crucial meta work, the coordination, troubleshooting, it all happens off-network on the centralized Mesh DC Discord. That external human layer is what dictates the network's effective utility, not just the radio waves.
I understand the importance you're placing on configuration, but I think you're confusing alignment with ongoing management. I would argue that the core stability is inherited from the physical environment. Elevation, unobstructive paths, these are the fixed, heavy-duty variables.
But they're not enough on their own.
The configuration fixes you described, disabling deep sleep, were simply one-time adjustments. They were needed to align the firmware's default battery-saving behavior with the established physical reality of continuous wall power. That intervention was only necessary because that physical reality was already guaranteed. You're describing a single technical decision. I'm describing the immutable physics that made that decision both possible and effective. Once the power was wall-socket stable, the real heavy lifting of network resilience was already done.
But that is precisely my point about human agency. The device defaulted to being a poor piece of infrastructure. If we define infrastructure by its reliability, then the owner's active USB-required intervention to override that default state was the act that created the stability. The device initially behaved like a gadget. It was oscillating between connected and asleep. That unreliability is the antithesis of infrastructure. You're suggesting the success was passive, but it was achieved by technical mastery overriding the hardware's default constraints. That requires a deliberate, conscious human choice, not just a lucky apartment.
But if the owner was living on the ground floor with patchy power, no amount of configuration would fix the physical limitations. The configuration merely optimized an already ideal physical situation. If the physics don't cooperate, the configuration is pointless. Physics is the prerequisite.
The physics is the foundation, but the configuration is the structure. Think about the social failure implied by unreliability. If neighboring nodes see this one constantly dropping out because of default power settings, they might actively route around it. Or worse, stop using the mesh altogether. The human choice to disable deep sleep didn't just fix a technical glitch. It fixed a systemic, social reliability problem that would have doomed the node regardless of its 8th floor view. This puts the human layer as the ultimate point of failure or success. And let's pivot to visibility, to the psychology of it all. I'd argue that the network's adoption is reinforced by abstraction and external legibility. Connecting to MQTT, which lets the node show up on that global map, was a key step in transforming the owner's mindset about what the node even was.
I'm not so sure about that.
Seeing the node as abstracted and detached, as more legible, it validates and encourages that infrastructural mindset. This metadata bubbling up to the web, confirming the node's existence to the whole world, it solidifies its collective purpose. Now, the data link itself, it does not affect local radio operation. I get that. But it's the psychological link that confirms the node is part of something larger, and that encourages the continued investment and management.
I'm just not convinced that visibility is essential for the network's core function. Local messaging still happens entirely over radio. The real metric of success was the change in local behavior, the shift from, occasionally detectable to continuously present. That was dictated by continuous power and physics, not whether the owner saw a blue dot on an internet map.
But you can't disconnect the tech from the community.
MQTT is a display layer. It's optional window dressing. The mesh layer is the utility layer. And that utility is defined by the physics of LoRa propagation. If the local network fails to route packets reliably, no amount of internet mapping will save it. The infrastructure exists to forward data locally autonomously. Its ability to do that without the internet is its primary measure of success.
But infrastructure is only infrastructure if it's used and maintained. The abstract view from MQTT is a necessary feedback loop for the people who build and maintain these nodes. It gives them a sense of participation, of impact, beyond their immediate radius. Without that validation, the motivation to keep that wall power on, or to do that difficult USB configuration in the first place, it starts to diminish. You have to acknowledge the human behavioral inputs that keep the physics optimized.
Which leads us right to the final point, the true locus of utility and the centralization paradox. I argue the observation that the RF layer does its job quietly while the human layer centralizes on Discord is actually a resounding testament to the mesh's success.
How do you figure that?
Because the mesh's utility is defined by its ability to route traffic consistently and reliably, allowing it to become boring. The goal is not interaction. The goal is forwarding. When the system just sits there quietly routing traffic successfully, when messages weren't just appearing, they were traversing, it means the fundamental physical and configuration decisions are stable enough that they don't need continuous human interaction on the RF side. That functional independence is the ultimate measure of successful infrastructure. The fact that humans centralize on Discord just proves the hardware is doing its job, freeing up social energy for high-level coordination.
That's a very efficient framing, but it ignores the fundamental fragility of the system as a whole. If coordination, troubleshooting, and regional awareness must live on a centralized internet-required platform like Discord, then we have to see the local radio mesh as just a robust but ultimately limited transport pipe.
It's a very successful transport pipe.
Yes, but the network as a complete system, the community, the governance, the ability to adapt to new firmware, it all depends heavily on that external human layer. If every time a new protocol is rolled out or a piece of firmware needs an urgent update, the coordination has to happen on a centralized server, well, how can we truly call the resulting system decentralized? The physical routing is decentralized, yes, but the glue that transforms individual nodes into a coherent, functional network is completely centralized and human-driven. That is a dependency that, to me, eclipses the local physics.
My thesis remains firm. The primary value of that Arlington Heights node stemmed directly from optimizing for physics. High placement, clear line of sight, continuous power. That is a hard prerequisite. The technical decisions followed from that physical reality. Success is achieved when the network becomes boring, when it just fades into the background.
And I still maintain that the physical layer is merely the necessary foundation. The ultimate utility, the stability, the adoption, it was all unlocked only through complex, deliberate human choices. Conceptual abstraction for identity, technical mastery to override flawed defaults, and the reliance on external channels for coordination. The stability is the result of human will and engineering, not just fortunate geography.
The journey of this one node really does perfectly illuminate that complex interplay between robust, decentralized physical tech and the necessary centralized human elements required to make them functionally persistent.
It forces us to recognize that even in systems designed for autonomy, long-term success often depends on thoughtful and dedicated human operators making conscious, non-default technical and social decisions. We're still left to weigh whether that core stability rests on passive presence or on active mastery.
Indeed. Thank you for joining us for The Debate.